Welcome to the T-Splines webinar, Engineering with Style. I'm your host, Matt Cederberg, co-founder and CEO of T-Splines, Inc. Tom Finnegan, T-Splines co-founder and head of development, is here to answer your questions throughout the webinar. So the way this works is that all webinar participants are muted. If you would like to ask a question during the webinar, just type the question in on the box on the side of your screen. Tom will be typing answers back during the webinar, and we will also answer any other questions at the end of the webinar. The goal of the webinar is to show how T-Splines for Rhino can be used to create smooth, complex surfaces that would be difficult to make in other solid or surface modelers. Then we will show how to export T-Spline surfaces to a solid modeling package. We will use Solidworks. And finally, how to add final details, integrate with solid geometry, and perform analysis on the model. We'll be showing all of this through the example of this joystick. Before we begin the demo, I'll review a brief overview PowerPoint of what T-Splines are and why they are useful in the design and engineering process. So T-Splines is a new surface that and also plugin for Rhino that allows you to create smooth organic designs, edit them quickly, and export them for manufacturing without remodeling. T-Splines are currently used in 5 industries. One of these is jewelry, and you can tell by these shapes the type of shapes that T-Splines are well suited for, more organic, free-flowing shapes. T-Splines are also used in consumer products. And you can see here, for instance, this chair, T-Splines is good if you need to create a free-form product that has a hole or a void in it. Also, as this razor shows, T-Splines can be used to create the organic backbone of a model, and then additional fine detail can be added with Rhino tools. T-Splines are also used to design vehicles. Just some things to point out here with this hole. T-Splines and its ability to have local detail make it useful for creating disappearing chines in boat holes. T-Splines are also used to create free-form toys. And finally, T-Splines are also used in architecture for more architectural sculpture and free-form architecture. Now, the reason why T-Splines was used for all these designs is because T-Splines offer some advantages to the technology currently used throughout CAD, which is called NURBS, or non-uniform rational B-splines. Just as a background, NURBS all have a rectangular topology. They're a smooth surface, but when you need to make a more complex shape out of NURBS, then you need to use a number of NURBS patches to comprise the model. That's possible, but it makes it difficult to have the patches all meet up in a watertight manner. And when you do get NURBS to be watertight, the models can be difficult to edit without losing smoothness, increasing model complexity, or even without gaps appearing. So T-Splines are a new surface type that was invented to solve these shortcomings in NURBS. And T-Splines they're a smooth surface, they're compatible with NURBS, but they have 2 key differences. First, with T-Splines you can have arbitrary topology in your model and keep it watertight. What this means is that you can have voids, holes, Y branches in your model, and it can still be one single smooth editable surface. Second, with T-Splines, you can have local refinement in your model, which means you can have detail just where you need it without having the detail propagate across the whole model, which makes the model easier to control and also to fare. These capabilities of T-Splines are made possible by 3 types of control points that are only found inside T-Splines modeling inside of CAD. The first is what we call T-points. These are used to end detail, and the surface is C2, curvature continuous smooth, right at that T-point. The second is star points. These are also found in subdivision surfaces, and in T-Splines these are G1 smooth, so you can still offset the surface right at that star point. This allows you to have non-rectangular surfaces. And finally, tangency handles allow you to control the tangency of the surface at interior creases and also at the edge of the model. So with that brief overview of what T-splines are, let's go ahead and step into the demo, which will comprise the rest of the webinar. During the demo, we will show how to create T-spline surface in Rhino for this joystick, then how to complete the assembly by adding additional details inside of Solidworks. And then we will show that this is a model that can be subjected to any type of analysis done in SolidWorks, and it will hold up as a good surface. So let's go ahead and switch over to Rhino. And here you will see, this is just a copy of Rhino 4. And the T-Splines plugin is these pink icons in that T-Splines toolbar. So T-Splines is a fully integrated plugin inside of Rhino, and many Rhino commands can be used on T-spline surfaces, and it's very well integrated. So during this demo, what we'll do is we'll show two ways that a T-spline surface can be created to make both the base and the handle of this joystick. And then we'll also show how to merge T-spline surfaces together and how to use T-spline symmetry to explore the shape of the model. So to create this joystick base, we'll just pick one of these curves and use the Rhino revolve command. So we'll just go open the surface menu and click revolve. Just revolve this around the origin. Let's see. Let's look at snapping to that. And just step through the revolve command. And now we've made, this is a NURBS surface, and later we will convert this to a T-spline, but that's how we'll get the base of our joystick. Now to create the top of this joystick, we're going to use a method called box modeling, which is a method you can use in T-splines, and you start with a primitive, and then you push and pull on that primitive until it arrives at the shape of your design. So we have some T-splines primitives here, and we can just choose the primitive that most closely approximates our final shape. So in this instance, I'll use a cylinder, and then I'll just have radius of 19, and then I'll just place the end of the cylinder here. Then just move the cylinder up into position so that it kind of lies where it should in the model. So now we have the two basic components of our model created, and we just need to make a few more modifications before we continue on with our modeling. First of all, the top of this joystick will be closed, and we have an open top to our cylinder. So what we need to do is we need to fill that hole, and we can do that just using the T-splines fill hole command. Just select an edge of the cylinder, and it will close that hole. You can see what this has done is it's created a smooth surface, but on the very top of this is an 8-sided face. T-splines allows n-sided faces in the model. However, if I zoom in on here, you can see that n-sided faces are not always the smoothest. And so we'll go ahead and divide this into some 4-sided faces using the T-splines insert point command. So this is just adding edges to the model and dividing that 8-sided face into 4 4-sided faces. So that's just cleaner geometry to work with. You can see there's even some artifacts of the n-sided face there. So to remove those, I'll use a command called the make uniform command, and that just will relax the surface and make it smoother and easier to use as I'm modeling. So now we've gone ahead and capped off the top of our cylinder and made it nice and smooth. And now we'll go ahead and merge the T-spline surface to the NURBS surface. To perform the merge, first we need to convert the NURBS to T-splines. And before we do that, I'll go ahead and rebuild this NURBS surface to make sure that it's degree 3 by 3. And then I'll also make sure the point count stays 8 by 8 so that the isoparms line up with the T-spline surface. It's not necessary to have the isoparms line up together, but it does create for a cleaner model. Now I'll just use the T-Splines merge command and merge from the T-spline cylinder to the base. You can see that that's created a nice smooth surface there. So now this is now a single T-spline surface. The final thing that I'll do before we start moving control points to get the shape of the joystick is take advantage of the T-spline symmetry. Since our joystick will be symmetric, what I'll do is I will select half of the T-splines model, and to do that I'll enter the T-splines edit mode and turn on face mode and just select these T-spline faces here on the side of the model. You select that curve. And then just hit the delete key, and that will delete half of the T-splines model. To apply symmetry, I need to make sure that all of my control points lie along the center plane. So first of all, I'll just use a Rhino command to project all those points to the C-plane. And now that they are lying along there, I can use the T-splines symmetry command to apply symmetry to the model. We can apply it in various directions, even radial symmetry. In this instance, we'll just do X symmetry, apply that, and this green line means that now I have symmetry in my model. So when I select a control point on one side of that line, you can see it will update on the other side. So now that we have this basic T-splines form, now we will move the control points to get the curvature of our joystick. So let's go to the right view. And first let me just turn on my layers and lock the reference curves so I won't be selecting them. And also I'll go to wireframe viewport. And I'll just use the T-splines manipulator to move the control points. So here we have the translate manipulator that I've been using. I'll switch that to the rotate manipulator. Press a hotkey to set the pivot point down at the base of the model and just rotate all the control points. I'll deselect this row. Again, change the pivot point down here. And continue this process to get some basic bend here with our form. Now that I have this model basically bended, I'll come in and move the control points some more to get some more to more closely match our reference curves. So this is kind of the key principle of box modeling, to use really a very small number of control points, but to move the control points so that they can match a reference image or reference curves in the back of in the scene. So I'm just moving these control points around. And this is looking a little bit better now. Let me go into the perspective viewport. I've just been working on in the orthogonal right viewport, but here I can come in the perspective viewport and also move some control points in these other directions. And this box modeling, this really gives you a nice flexible model that you can use for your form finding. So move these control points around and see how that's looking. One part of the model right here for the trigger will be difficult to have the surface flow through here with the number of control points that we have. So we have a couple options. First, we could add a lot of control points and then pull them out, but that gives us kind of a needlessly high number, and then it will be difficult to smooth the model afterwards. The second thing we can do is actually add some more faces by kind of constructing them and putting them into the T-spline surface. So that's what we'll do. And anytime that I I'm adding and deleting faces from the T-spline, I like to switch modes. This is what we call the smooth T-splines mode. We also have a mode that we call box mode. So you can click the smooth toggle icon and select the T-spline surface. And you can see how it now is represented as a boxy mesh. It's still the same model, and the control points are in the same locations between the smooth surface and the boxy mesh. But this just gives me a little bit easier way of understanding the topology of my model and where all the faces and edges are located. So what I'll do to add some geometry here is first I'll actually delete some faces. I'll go to face mode and select those faces and just hit delete. And you can see since I have symmetry on, it's deleted on both sides of the symmetry line. Now I'll go to edge mode and select an edge here and extrude that edge. So I'll use the extrude command. And what that's doing is you can see that adds geometry to my surface. It's added that face that I've extruded. So I'll go to vertex mode and kind of move these vertices around so that they kind of come into the position where I want them. And then I can go ahead and go to edge mode and extrude this edge again. Go to the extrude icon. And you can see that it's being extruded since I have symmetry turned on. It's being extruded on the other side as well. I'll go to, let's see, vertex mode and pull this down to kind of make the trigger a little bit bigger. And now I'll go ahead and use the T-splines weld command to weld these points together. So you can see symmetry is still on. I've welded that together. So now I've added some geometry here, but I still have these gaping holes. We used the fill hole command before to fill in the surface, and I can use that as well here. Another command we have to fill holes is the append face command. And so I'll just use that this time. And to use that, you just click on the corners of where you want the new face appended, and then just hit enter. So we'll do that again. So just click on corners of where you want the face to be. And this gives you a little bit more control than the fill hole command as far as what your face looks like. So now that we've filled those in, I'll go ahead and hit smooth toggle again. And we'll go back to see what the smooth surface looks like. And you can see that we've now we've added, let me see if I can change that view a little bit better. We have now this star point here. We have another star point here, which means we have some non-rectangular surfaces, or a non-rectangular surface, which is nice because this is kind of a non-rectangular area here with the trigger. So I'll go back in my right viewport and turn on my vertices and go ahead and just reposition the surface. It looks like I pulled this up higher. I can bring that back down. And just kind of reposition our surface so that it's matching what we had laid out with our kind of that sketch of our curves. So now we have a trigger area. Let me turn back to shaded for our model. We will add two more parts of detail before we bring this model into SolidWorks. First of all, we need to have a hole here in our model because this is where the kind of the plate will go on for the joystick. And if you want a hole in T-splines, you have two options. First of all, you can just trim the T-splines model using the Rhino trim command, and it will turn into a NURBS, but you'll get an exact trim. And that's often a good approach, but when you do that, then your model is no longer a T-spline. The second thing that you can do is just delete T-splines faces. So that's what we'll do here. I'll go to face mode and select these faces. Before I delete them, I'll go ahead and extrude the faces, just like we extruded edges before. So this gives us just additional faces in the model, and I'll scale them inwards just to add a little bit nicer ring to the edge of the deletion. And now I'll hit delete. So now we have a hole there in the T-Splines model. And again, what the extrusion did was it gave me a nice ring around the edge of that hole. Now what I want to do is I want to match the T-spline surface as close as possible to this curve which I've laid out. And we have a command in T-Splines to do that. It's called the match command. And it can match the edge of a T-spline surface to any curve or NURBS surface edge. So before that match, I'm just going to pull the surface a little bit closer to so that the match is less ambiguous how the match should take place. And okay, so that's looking a little bit better. At this point also, I'm going to turn on my layers and move ahead to another layer that I had prepared previously, because when we move this model into SolidWorks, I want to make sure that the different features are working in SolidWorks. But this is basically the same model that we've been working on today. And now with this edge close to that curve, I'll go ahead and use the T-Splines match surface command. So I can just double-click to select this T-Splines border edge, and then I'll select the edge that I want it to match to. And it looks like, actually, I better turn my layers back on and unlock those curves so I can select this curve. And then, let's see, it looks like I better run the match command again. And then, so I just want, it gives me a little dot here, and I need to click opposite that dot on the curve so that it knows where the seam of the match should be. And I can just move this seam so that it's in a good location, so that there won't be too much twisting. And then I'll just go ahead and hit enter. And I have an option to refine. If I do refine the surface, then it will add more control points, but it will get the T-spline to within file tolerance of that curve. So it will really match that curve nicely. This will disable symmetry, the match command will. But you can see now how closely that T-spline is matching that curve. It's within your file tolerance. So you can see it's added some more detail in order to do that match. But the nice thing with T-splines is that detail can be localized. And so down here on my model, I don't have any more detail needed because I can just, the detail will just be teed off here. The final feature that we'll add is a local T-splines crease. T-splines have the ability to have creases that only go partway through the model. So I've just selected this edge loop, and I'll deselect some of those edges. And then I'll just use the T-splines crease command. This will give me a perfectly sharp crease in my model. So we can zoom in and see how that's giving me a perfectly sharp crease. The tangency of this crease can be controlled by these special T-splines tangency handles. You can tell that they're colored white. They're a different color than the other control points. And they can select those control points. I'll change my manipulator drag mode to UVN, so I can drag those perpendicular to the surface and change the how the surface is, the tangency of the surface around those tangency handles. So you can see as before, the surface kind of peaked at the crease. Now the crease is kind of going into the surface. So I can just do that on, I'll do that on a few more of these. Let's see, make sure I have those selected. And I can just go around my surface and adjust the crease so that it's coming in with the tangency desired. Okay, so this is basically the model that I'm ready to bring to SolidWorks. And because SolidWorks does not have T-splines natively today, what I'll need to do is convert this to NURBS. But converting T-splines to NURBS is just a push-button operation. You can see here's the T-spline surface, and to convert it to NURBS, I'll just click that icon and click the T-spline. And you can see the actual shape of the surface doesn't change. What does change is that the T-spline needs to be split up into rectangular NURBS regions, because NURBS all have to be rectangular, but the actual smoothness of the shape will not change at all. So now to bring this into SolidWorks, I will just save this as a T-spline. or I'm sorry, save this as a Rhino 3DM file, and then go into SolidWorks. And because SolidWorks does open Rhino 3DM files, I can just open up that Rhino file here in SolidWorks. And click on the T-Splines, click on that joystick. I'll go ahead and run import diagnostics, and there's a face to heal. Go ahead and heal that. The gaps, of course, are desired in the model. So we'll go ahead and finish import diagnostics. And this T-spline surface is as good as any watertight NURBS surface brought into SolidWorks. So you can see it's just a surface now, but we can thicken the surface. So maybe thicken it to maybe 2 millimeters. And turn this into a solid. So you can see now this is a solid, and then we can perform any other operation in SolidWorks on the model. So I've gone ahead and saved these ahead of time. But so here we're at the point where we've created a solid. I'll just kind of step through the feature tree just to illustrate how this works just like any other geometry in SolidWorks. We can cut away at the model. We can add some ribs, perform some extrusions, some additional extrusions, add some fillets to the model. Let me rotate just to kind of show how those fillets are being applied over here on the opposite side. And just treat it like any other geometry inside SolidWorks. So now we have that nice organic T-splines base of our SolidWorks model. And of course we can create a larger assembly with this as the basis. And again, here's our T-splines piece inside the larger SolidWorks assembly. The T-spline surface can be subjected to analysis just like any other SolidWorks model. So here's some analysis showing the flow of how the injection would take place. You can see this is a nice, healthy surface. Let's run that again. And then also we can just observe the different analysis of what happens when different pressures are applied to the T-spline surface, and you can see that the surface behaves well in this type of analysis as well. So, so that's kind of the purpose of this webinar, is just to show that T-spline surfaces are compatible with NURBS and can be brought into any solid modeler and used in a design for engineering and manufacturing. So one question that might be asked is, once we have the T-spline model inside SolidWorks, what if we want to make a change on the actual T-spline surface? Well, that's easy. We can just go back to Rhino, and let's undo some steps. So we go back to the T-spline model, and let me go back to shaded mode. So for instance, maybe I want to remove the crease in the T-spline surface. So to do that, I'll just use the remove crease command, just by right-clicking on the crease icon. And I'll just select the whole model, so all the creases in the model will be removed. So you can see that's nice and smooth now. And maybe I want to explore the design of my T-spline surface as well. So maybe I'll just turn on the faces, and maybe I want to drag out one of these faces to add some, a different feature here in the joystick. Well, when I make these changes, I can just bring this T-spline back into SolidWorks. So I'll go ahead and hit Save As and save it as the joystick again. And then back here in SolidWorks, we'll just go back to our T-spline model. And here at this step in the feature tree where we've imported the T-spline surface, I can just go ahead and edit this feature and load in the new T-Splines file. Now this will take a few seconds as it's kind of recomputing that and trying to rebuild the feature tree. And there's a good chance that depending on the extent of the changes I've made, maybe some of the features will not be able to be rebuilt automatically. But it will be possible to kind of make changes on that feature tree and see how the model looks with this new T-Splines geometry. So let's see how this is looking. It looks like these features are no longer working, so we'll need to edit those features and identify where kind of in the new geometry where the features should correspond to, and that will go ahead and let those features be redone. And we'll go ahead and do that again with this one. Edit this feature, and looks like we need to identify that it will come up against this face. And so now we've been able to bring that T-spline model back into Solidworks and make sure the features are working so that we can check out how this model will, or how this design will work for us as well. So that's the webinar that we have prepared for you today.